Okay, this is post lecture, chapter 10, problem 2, I think it was. No, this was 3, right? Yeah, that's 3, part A. Yeah. Okay, so anyways, you have a weak acid, phosphoric acid. This has 3 acidic protons that are highlighted in red, and those are those ones right there. As a weak acid, some of the acid will remain in a molecular form when dissolved in water. Write the net ionic equation that depicts the dissociation of the first proton, including charges for any ions produced. Okay, so we only have to put in the stuff that's actually doing work, that's actually directly involved. So this actually makes it quite easy. So you're going to start off with H. Are you kidding me? What the hell? It literally, when I touched the tablet, it stopped, it turned off. I guess the timing just worked out. So literally. Anyways, weird. So you have H3PO4. Your problem actually told you had that, right? And you have to start off with that. And so this is a weak acid. It's dissolved in water, and that means we have to say it's aqueous, okay? Dissolved in water. Some of the acid will remain in molecular form when dissolved in water, and some of it will donate its proton and act as an acid, right? And it literally tells you you need to have the first proton being donated. We're not given any base here, and so our base has to be water, right? Remember, the water can be both an acid and a base. So whichever one you need it to be, it can be. Okay, and so this is going to be plus H2O. Now that is in liquid form. That's not aqueous because water can't dissolve it. Well, water dissolved in itself is not a solution, right? Okay. And this is going to be in equilibrium because this is a weak acid, meaning it doesn't fully dissociate. Some of it will come back together. So we do equilibrium. Now, every time you have an acid-base problem, we're talking about an acid is going to be donating a proton, right? So what does that mean? Well, we've lost an H, so this number here has to go down. So we have to do H2. The PO4 stays the same because that's not an H. We're not losing any of that. And then, well, we've lost an H plus, right? So we lost the H. How do we lose a plus? Well, it goes from 0, which is what nothing up there means, 0 charge, to a negative charge, right? There you go. And then that's aqueous because it's still going to be dissolved. The other thing that you have here is going to be, well, where did it lose the proton to? It lost it to water, right? And so now that water has an extra hydrogen, meaning a 3 right here, still has the oxygen, and it gained a plus charge from gaining the H and the plus, right? And that now is no longer water, so that is dissolved in the water. That is aqueous. That's called the hydronium ion. And that's it. Because all we have to write out is the stuff we need. We don't have to write out anything else. And technically, you don't even have to write out the aqueuses and liquid and stuff. You could have actually skipped those. I just did the proper way of doing it. So you could have skipped these, and it still would have been right. Okay? And remember, whenever you're talking about acids and bases, if you're talking about an acid, it always donates one H plus. And so it always loses one of its H's and a positive charge, meaning it gets more negative. And then the other thing in there, whatever is the base, always accepts an H and a plus charge, okay? And so they're actually like really, really super easy once you get it down and you start being able to do them on your own. Once you get down, it's really easy. All right. Okay. Did that answer the